I can do it.
You have for
Is there anything that we can go ahead with while we're working on this and then come back?
The petition, I guess.
Yeah, let's go to number 8, proposed petition to modify Texas Railroad Commission rules for notification and application requirements for oil and gas waste disposal wells.
Okay, let me just give you the full rundown and the background on this thing. This thing didn't pan out as an agenda item for this meeting like we wanted it to, because we still don't have our final draft on this, so we're not really gonna be able to take action on it today, but I put in front of you a petition which is still being under review. It says second review up at the top. What this started from, I got a call from an individual in Victoria County, I guess before Christmas. Her name is Lisa Campbell. I wanted her to be here at this meeting today, but she had to go to California this week. So she is a registered nurse in Victoria County. She works for Victoria County as a public health nurse. She also teaches nursing and public health related type courses at Texas Tech University via online type courses, however that works. And she travels to Lubbock once a month to take care of whatever she needs to take care of up there. She kind of took this upon herself. She saw an application in the Victoria County paper. The application was for an injection well that was actually in Calhoun County. And she went to the Commissioners Court meeting after she saw that, and in public comment expressed some concern about that and wanted to get herself educated as far as what that was, how does that relate to public health, that kind of thing. She expressed some concern about the injection well and where it was located. She had talked to some of the local residents, I think around the Bloomington area. They also had concerns. So after the meeting, a couple of the commissioners from the Calhoun County Commissioners Court got with her and said, Lisa, can you help us with some of these injection well applications? We are also concerned about some of these applications. So she has basically kind of taken it upon herself as an individual, and with her work and knowledge in nursing and public health for Victoria County, to try to come up with a petition to make sure that groundwater conservation districts and that all adjacent landowners are notified on these applications. One of the commissioners for the Calhoun County Commissioners Court is good friends with Todd Hunter in Austin, representative. And Todd Hunter told them that if they can put together a petition and get some of the GCDs to sign it and get on board with it, that he would arrange to have a hearing or meeting with the Railroad Commission and all the constituents on the petition to try to get the rule amended to where GCDs are included in the notification process and also adjacent landowners. I met with Lisa, I guess last week. She had presented the first draft of this petition. The one that you see here has already been edited a bunch. I had some areas of concern on that we looked at. This is kind of our second go-round here, and I do have some additional comments here. Like I said, she was in California this week, so she couldn't really get it done to get a final draft back to us for this meeting. So what we're going to do, she has already contacted the Goliad County Groundwater Conservation District. I talked to Barbara Smith yesterday. She's the manager there. She's going to take that to her board. They also had some comments and concerns about the petition. She's talked to the Pecan Valley GCD, which is DeWitt County. She's talked to Tim with Victoria County. And she has also talked to one of the board members at the Winter Garden District, Ed Walker's district down there, as far as the petition goes. So right now, as it stands, we are still kind of in the review process here, and These are some additional comments that I had, the red lines that you see there. And like I said, this has already been edited quite a bit. There was a lot of stuff taken out. I did express a couple of items of concern to her. The second one is create a mailing list of interested persons. I wasn't sure how that would work. To me, you know, that sounds like anybody in the general public can request to get on a mailing list. I told her that needs to be narrowed down, at least to, say, adjacent landowners. And also a listing of the chemical composition. I explained to her that it's kind of difficult to really narrow down the exact chemical composition of what's coming back out of the well. The constituents that go into the frack water being that's used in the fracking process is disclosed in the Frack Focus website. But so anyway, she was going to get with her attorney on the wording on that and see if they wanted to leave that in there and see where that goes with the Railroad Commission. So anyway, it was still kind of preliminary here. Hopefully we'll have a final draft for you to vote on at the next meeting. And she is, hopefully by then, all the other GCD, their boards members will have looked at it, made their comments and edits, and we'll go from there. I told Lisa that TAG had tried to get something like this done a couple years ago, had gone before the Railroad Commission, and it looked like maybe they were gonna change their rules in order to notify GCDs, and then when it came down to the final vote, I think we just kind of fell through. But the saving thing, I guess, with the Railroad Commission now is that it's all under pretty much new leadership. You got Christy Craddock now, who's at the helm, and she appears to be really doing some good things here at the Railroad Commission, at least from some of the things that we've seen here in the office. And they also have just recently named a new director of the Oil and Gas Division. I don't remember what her name is. It was in the paper, I think, last week. So it appears that they're doing some good things there. And hopefully, it may be a long shot, but if Lisa can take this on and is willing to give it a shot and push this thing through, it would be great.
And Todd Hunter is willing to back it, or
Yes.
at least to carry it forward.
Todd Hunter
We know him from
is-
Corpus Christi's
is
representative.
good with one of the Calhoun County Commissioners, and he is the one that told him that if y'all can get this pushed through, I will arrange to put this before the Railroad Commission. I don't know what that process involves as far as getting it before them, but,
Did he,
so.
was he on the Natural Resources Committee? I think the state, the state rep,
I'm not sure if he's on the House Natural Resources or not. I think he is.
I think so. He has some influence.
Yeah.
He was on that joint commission.
So,
I applaud
anyway,
what
like I
you've
said, we can't really take action on today because we're just not at that point yet. But I would like for y'all to review that, and between now and the next meeting, and by all means, any other comments or concerns or anything, please let us know, because we're still going back and forth on the revisions. So,
Well, what little time I've had to read it so far was, certainly has some benefits.
I told Lisa, if nothing else comes out of this, if we can at least get it changed where they have to notify the adjacent landowners and the GCDs. If they can accomplish those two things, then that's a major, major hurdle. I think the rest of that will fall into place after that. Right now, the way I look at it, the way I see it, on a W-14 application, the adjacent landowner only has to be notified if the application is for a commercial disposal well. So,
Well,
And they
they
don't
also
always
have
all
to-
get notified, Russell.
what's that?
They don't always all get notified, and
Okay.
they just sort of say, oh, well, too bad. No.
And
Surely
they
they
do have to
do.
research all the wells of public record within a half-mile radius of where the injection well is located. And there's another letter before y'all from the Railroad Commission. We'll get into that in director's discussion, but that's a result of one of the protest letters that we did. We'll talk about that in staff discussion. But anyway, as far as this agenda item goes, that's where we're at. I was hoping to be a little bit further along than what we are, but for sure it will be on the agenda for the next meeting.
Thank you, Russell. Let's go back back to number 7, update. Are you ready?
Yes, sir.
Okay.
Yes, sir. I think so. Are we ready or?
Well, we're close enough.
We're close enough. We'll see if we can.
We know air
Of course,
races.
there, isn't it?
Nice plan.
Super 14.
Is that better?
Yeah.
Oh,
I'm gonna go down and sit in though.
is that how I?
It's in PDF, it's not in
Great.
PowerPoint.
Oh, this is really fantastic. All right.
Well,
All right, well, this is going to be the first update for the study that I'm conducting with both the Evergreen Underground Water Conservation District and the Winter Garden Groundwater Conservation District, as well as Baylor University, which has also contributed some of the funds for this project. And what I'd like to talk to you all first about is just a brief overview about the project. It's been a while since we talked, so just going to go over the project again, and then give you all a little update about some of the recent research that we've been doing. And this is a joint project funded by 2 groundwater conservation districts, as well as Baylor, and the official start date was in October of 2014, and the project end date will be May of 2016. And the challenge is, what we're primarily interested in is characterizing abandoned wells and their relationship, both spatial and temporal. And primarily, and that's because the science behind many of these has not been completed yet. So this is just going to go into our process of understanding how these wells function. So why is this study important? What we're interested in, the overall theme, is to examine what conditions, if any, would have to exist in order for an aquifer to be impacted, potentially impacted. And that's mainly because sampling a water well, and I think Russell brought some excellent points, sampling a water well for an impact doesn't tell you anything. All it does is result in more questions, such as, if a water well is not impacted, if there's nothing there, well, what if the impact is just not yet reached that aquifer or that well? Or what if the impact has reached the well, but the method that we use to sample it or the laboratory, we couldn't detect it? Or third, which is often the case, well, what if there is no impact? Or what if it is impacted? What if there's some type of impact in the well? Well, we have a number of questions, such as, well, where did it come from? How did it get there? Did it come from the surface? Was it a surface flow? Is it natural? When did it get there? How much of it is there? And where is it going to go? Is it going to stay there? Is it going to move? And these are all very important questions. And that's why just sampling a well and looking at what's in the well is, as I mentioned before, just results in more questions that we want answers to. So the project scope, for this project, we're interested in conditions that may influence transport. And for the location model, we're interested in how many of these wells are out there, where are they located to more modern wells. And then the water chemistry, which is simply how would we go about identifying an impact. If, for example, somebody has raised a concern about one of their wells, how would we go about initially reviewing that? In summary, if these wells are a risk, then these projects combined, that will assist with developing a strategic plan for how to evaluate these and potentially deal with these if they need problems that they need to be addressed. So the deliverables for the Evergreen, all of the abandoned well data, well integrity data, and I plan on, I have access to be able to print all of the well maps that y'all need and where they are, both in print and electronic. That's producing wells, abandoned wells, injection wells, rig wells, everything. And I know that the Evergreen has already done a significant amount of work on that for GIS, and I think this will be an excellent complement to that y'all can for y'all's records, as well as any of the chemical data and all of the reports that I'll be writing up. So here's let's take a look at some preliminary samples. I took a number of samples in LaSalle County, and those included crude oil, produced water, groundwater, and some samples from a frac pond. And you can see the two wells that I sampled for the crude oil are located in the top right, and those were also the wells I gathered the produced water from. And then there were a number of frac ponds surrounding these well pads that are also worth sampling, because the frac ponds are groundwater. So they're groundwater that's pumped out and stored on the surface, which y'all are familiar with that. There's, just to give you an idea, preliminary samples, what they would look like. So this is Carrizo-Wilcox groundwater. This is in LaSalle County. It came out at 106 degrees Fahrenheit. The TDS is excellent. It's a deep well. It's a 2,000 foot well, and the pH was right about 7.1. It was fantastic. I drank some of that. It's really good. The frac pond water, which is that Carrizo-Wilcox water, pumped into the pond but stored over time. Why would we be interested in that? Because we may be able to differentiate between something happening in the subsurface and something being linked to the surface. So we want to get an idea on that one as well. And then here's what they dispose of in injection wells. This is, so on the right-hand side, what you're looking at, this is produced water in the Eagle Ford Shale, and both of these are disposed of versus in Class 2 injection wells by the Railroad Commission. The temperature in the tank at the time of sampling was 88 degrees Fahrenheit, but the TDS, 67,000 milligrams per liter. And that sounds high, but in reality, the fantastic thing about the Eagle Ford Shale is that, number one, there's not a lot of produced water, because there's not a lot of natural water down there, like with normal shale plays. Versus if you went to the Marcellus, the produced water, which is in Pennsylvania, it's a shale play in Pennsylvania, the produced water there, the TDS is 300,000 milligrams per liter. And so this is really good, that it's low TDS. In addition, when they inject it into the subsurface through the injection wells, the clays that are surrounding the injection wells, if you have relatively fresh water and you inject that, it'll swell those clays up, and that injection well will, it's going to shut down. Exactly, yes sir. So you want it to be salty. You want it to be salty when you inject it, because it works just like a magnet. And these are, anyways, pH is 5.5, and the difference between those two, I'm sure you're interested. On the left is yellow, on the right is black. The left one has been sealed. In fact, you could, I don't know if I can, I don't think I can do that. But if you look on the top right, there you can see the cap is kind of concave, and that's because that was one that I was sampling for radon a number of analyses, and all of the metals in there have oxidized, and so that's why it's black. Yes, sir.
Releasing the oxygen.
Yes, sir. So what do these look like? We put them in a machine, we run them. What do they look like? What does a signature look like? If I put crude oil in an instrument, I ran it. This is Eagle Ford Shale crude oil. This is raw crude, and all of these peaks, these little pops, are the fingerprint, effectively the fingerprint for different compounds. So they're just different chemistries. And as a whole, this makes one big fingerprint. So if I looked at this on the surface somewhere, I could compare it to somewhere else on another tank or another place on the surface and say, oh, they're similar. That doesn't mean they're the same. It's the same thing as in the water, but it gives you a fresh start. Going even further, here is Eagle Ford Shale crude oil and Eagle Ford Shale produced water. So this is the fingerprint for each one. And
The scale's the same?
yes sir.
You should be able to zoom in on that.
Oh really?
I would think.
Okay. Oh yeah, I can zoom. Man, this is really good. You guys are great.
Speak for yourself.
You guys got better technology than Baylor does. I mean, this is. So the X scale, on the X-axis, it's the same, from 0 to 70, and then right here on the Y-axis, 0 to 100. But the green bar that I drew on there, if you notice, I know the numbers are hard to make out, but focus on the peaks. The peaks are very similar. And so what that's indicating is that the fingerprint for each one of these is similar. Now, why do we care about that? Well, this is what they're injecting. They're not injecting that. That might be related to a surface fill, but this is related to injection. And so you might be able to say, and I say might be able to say, trying to be very cautionary about this because there's a lot of science that still needs to be done. And it's a process, it's a long process, but this is the preliminary results of, maybe we can say there's a match here. Maybe this would be useful for us. So what about the Carrizo well and the frac pond? As I mentioned earlier, the Carrizo well is about 2,000 foot below ground surface. The frac pond, it's the same thing, it's just stored in the surface. And I know there were a lot of people at first or a lot of companies, operators, that would come in and they would line these frac ponds. Of course, if you're a South Texas cattle rancher, if you've ever gone out there, you look at your pond, it's completely, the cows, they've completely torn up everything. So they would tear up the liners and they stopped doing that, but the clay's holding enough of the water. I thought that was really interesting. I remember going out there as a young boy.
Willing to let them drink that produced water, or is that fresh
This
water?
is only fresh water. They do
Only
not
fresh water,
store,
okay. It's not produced water.
they cannot store produced water in an open
Gotcha.
pond like that. And these are lined, the natural clays here in LaSalle County, there's a lot of smectite in them. And they actually, if you pick a good place to build your pond, it actually seals up pretty well. So you don't even need to, even if you could line it, you wouldn't, why? It works great.
If they line it, can they store return water in it?
No, they cannot. They have to store that in tanks.
I think only if it's an emergency situation.
That's correct.
Yeah.
It would have to be an emergency situation. Now, they could store drilling mud in there if it's lined, that they're recirculating in the hole, but they can't store produced water in there, or frac fluids or anything else. So it's all fresh water. And, where's my, oh, yeah. So just to give you guys an idea, what we were first looking at when I was showing you all the fingerprints, those were all organic compounds, and this is the fresh water, Carrizo, Wilcox, and surface water, and so they don't have a fingerprint because there's nothing in them. So water was great. So this was just the preliminary round of looking at these fingerprints, but very tasty water, excellent water. And just to give you guys kind of an update where I am, I was teaching in the fall and taking classes full time, and I wanted y'all to know I'm finished with all of that, and because of the support by the Evergreen board, I'm 100% on this now. I've been working on it every day since school started, before school started, but every day. So
Full-time job.
I'm a full-time temporary Evergreen employee. So I just want to say thank you guys for that, because I really appreciate it. Not that I don't like teaching, but
What you're indicating is that in the Carrizo water, there was no organic.
yes, that's correct.
Even though it's 5,000 or 6,000 years old, but there's nothing
Well, I know, but what we said,
There's no fauna.
we end up with
no
some,
flora.
I guess
some charcoal in there every once in a while.
I guess I shouldn't say there were absolutely no. You do get some peaks for bacteria, and when you run them in the samples, it'll basically take those bacteria and just emulsify them almost in the. That's not the right word.
So there is coliforms there, they're just not toxic coliforms.
Yeah.
that
Yes,
you
sir.
can use, so.
Yes, sir. That's correct. I didn't mention that because it wasn't a.
Okay.
Insignificant.
Yeah, it's yeah. Yes, sir. But there's organics in bacteria are ubiquitous. They're everywhere. So that's not something that's surprising to us. But for the next update, and I'm working on this issue right now, I'm working on the modeling, I'm working on how many wells and the well locations and working with a number of stakeholders on this issue. And I will have, present the next update to y'all, which I think you guys will really enjoy.
How many wells do you hope to have in your study? In terms of, I guess you're gonna be looking at what the wells in the old abandoned oil wells, is that where you're
Yes, sir.
headed?
Yes, sir. We're primarily interested in obtaining crude oil samples to do many of those fingerprints, produced water samples to do many of those fingerprints, and then down the road, we would like to, of course, evaluate a number of groundwater wells. That's correct. And as for how many, that's a tough question because we don't know how many there are and where they are and the ease of access. But I mean, I would love to have at least 20 of each. So I feel like that would start to give you a good idea on things. And I mean, if I could do 100, I would. And working with landowners and working with the groundwater districts and coordinating this between everybody it's a lengthy process to.
I assume you're gonna try and find ones that have some proximity to existing fracked wells, is that correct?
Yes.
Okay, you have any idea of distances I know it's gonna be what you can find, but you have some idea as to how close you wanna see these, old well abandoned wells where you sample water from?
We haven't, that's what I'm in the process of working on right now. I'm not certain as to what the distances that we would be, interested in, but whatever distances we choose will be based on the regulatory specifications and the prevailing science. So I mean, they will have to be, this whole study, we have to be very, very careful and cautious not to be, alarmist about any of this. This is just a purely science, study to evaluate this issue. It's part of my dissertation, and I think it will answer a lot of important questions for y'all in the end. So those I'm still working on because it's not as simple as at first I was looking at it, well, we could do this kind of spacing, but really got to be very careful about what we choose to make sure that not that we get an answer, but we get the right answer. That's the important.
Unbiased answer.
Yes, sir. Yes, sir.
Got it.
Because it's more than likely that they're okay. I mean, there's not a problem. I mean, but we don't know.
Find out.
Yes, sir. So, I mean, thank y'all. Like I said, thank y'all so much. Really appreciate it. It's been really interesting. My wife's been, asking me about this research a lot. She wants me to graduate, so she's always. Are you going? Doing research today? I'm doing it. So.
You have a strong incentive to get.
I promise you, I have a very strong incentive to do a good job on this. So.
Yeah, we understand that kind of motivation.
Do y'all have any other questions I can answer for y'all today? And I'll stay after as well to say hi to you guys.
Where is TDS gonna be fit into this? Then what? The material that they're calling TDS then is not organic, it's inorganic?
It's a combination of both. So in some of that produced water that flows back out, some of it is an emulsion of oil and water. And when they take that to the injection facilities, a lot of the injection operators that's how they make their money. They skim some of that oil off and save that before they re-inject it into the subsurface. You can't get it all, but I would just as an opinion, I'd say there's maybe 5% of that is hydrocarbons, so oil, 5% of that bio, and in fact, I'd say about 5% of that is hydrocarbons, and then on the on the right there, the darker one, the black is just the metals, they're just oxidized metals. So it's zinc and a number of other things such as barium and manganese and all that good
Monterey.
stuff. Yes, sir. So as far as where does TDS go, the importance is characterizing what compounds is in the TDS. Although it does give us a good benchmark, because TDS tells us one thing about the water injected. It gives us an idea about the density. Because if I have something that has a whole bunch of TDS, it's going to be a very dense fluid versus something like and it would layer underneath a less dense fluid like surface water, groundwater with low TDS. So that's one good thing about knowing the TDS.
That would be your first indicator, in other words,
Yes, sir.
for the most part.
Yes, sir. That would be a good indicator of maybe we need to, take this another step, and then another step, and really see. The challenge is with this, it's not, just looking at and not to go on at, for infinity here, but you have to have the right end members. So in other words, if I had a well and I thought that it was, impacted by hydraulic fracturing or an injection well or something, the key is you have to know what the hydraulic fracturing fluid or the injection well looked like, what they were actually injecting. You would have to know what your stuff looked like before they started injecting. And then if you looked at your well and you said, well, it's somewhere in between here and it matches up to this, that doesn't guarantee 100%, but it suggests it's likely that that's where it's coming from. And so that is extremely important. And that's why one thing I know that landowners in other states and just some of the stuff that I've read, you can't just look at the well and just say, oh, I know what's wrong with that.
You're not gonna be able to get the chemical composition of the injection fluids, actually, at the time it's fracked. But at least maybe the produced water will give you some clues of what's in there.
Yes, sir. That is exactly right. Every single site that people use, or that operators use hydraulic fracturing at, they use different fluids, different compositions, every single thing. So you have no way of knowing what was the original composition. And that's okay, because once they inject it, the majority of that is dominated by what was in the subsurface that comes back out as produced water. And that would give you an indication. But yeah, there's a lot of very interesting.
Well, I'm just trying to see, since you won't really be able to get the exact
Yes.
composition of your injection.
And that's why we're not really interested in the hydraulic fracturing portion of it. That's not, the hydraulic fracturing is, it's fluids moving up from, great depths. That's something totally different. And, fluids flow from high pressure to low pressure. They don't flow up or down or right or left. So, but, sorry guys, I know that was long.
You had another slide with a bottle on the far right that was very dark. What is that just the oxidized metals again, that very one that
On
seemed to
the
be
far
dark?
right, that's correct. That is zinc, manganese, magnesium. There's a lot of metals in there, and most of those metals, a lot of them aren't from the actual frac fluid. Those are just from the shale. A lot of those metals are so shales are very negative, and clays in general, they're very negatively charged, and the metals are positive, and so you get a lot of these cations or these positive metals that stick to the clays, just like a magnet. And then when you flush it out, sometimes they can release some of those. So most of it's natural, but if you open it up afterwards, it'll start to oxidize, just like iron. When you turn on the well or you turn on the faucet, excuse me, and your well water, as soon as it's coming out, it's red, or orange.
I've seen it very clear, and if you set it in the bottle for a little while,
Set-
24 hours, you get an orange deposit on the bottom.
Yep.
Obviously oxidizing at that point.
And that's that iron, going from +2 to +3, so it changes change of state in there. Yeah, it's pretty cool. It's very tasty. In fact, the Carrizo Wilcox water, I drank a lot of that water preparing for this, so, you know, the Carrizo Wilcox water is some of the best groundwater I have ever, you know, I've lived up in the Panhandle, the Ogallala, and then Waco, it's mostly Trinity, and then I grew up over the Edwards, and then my grandparents were here. It was mainly Carrizo Wilcox. You know, there's other aquifers, of course, but that water, the TDS is so low, the pH is like perfect. It's the best water I've ever had. But it does usually have a little bit of high iron. It's the one thing that's kind of neat about it.
I got a call from someone that their clothes were getting orange, their shower was getting orange, they just didn't have the right oxidation set up, and got that worked out. Because when I take a sample of the water a few days later, it's
You just said,
orange goo on the bottom.
yes, sir.
When they got the oxidation system right, it cleared up.
Well,
Any other questions for Josh?
Thank you, it's very good.
Josh, once
Very good.
again, we
Thanks, Josh.
appreciate it.
thank y'all.
It's very
I couldn't do it without y'all. Thank you.
Don't worry about all that.
Oh, don't.
Yeah, I gotta go back.